Okay, this is quiz 4. The first question says, show that the equation x cubed plus x to the fourth equals 10 has a solution c. What can you say about where c is on the real axis? Okay, now this question is pointing you towards the intermediate value theorem. Just so that we can really be clear about what we're talking about, I like to rewrite this equation. Rather than x cubed plus x to the fourth equals 10, I'm going to rewrite it as x cubed plus x to the fourth minus 10 is equal to 0. Now I can really see how I can apply the intermediate value theorem. I know then that if I find a place where this function, x cubed plus x to the fourth minus 10, is less than 0, and another place where x cubed plus x to the fourth minus 10 is greater than 0, then between those two x values, there's somewhere I have a 0. Now, notice one important factor of this this equation, one important thing about this is that this is continuous. Right? If we didn't have a continuous function, we wouldn't know for sure that there was going to be a solution in our interval. We'd have to make sure that we don't think we have a solution somewhere where there's actually a discontinuity. But this is continuous. There's no problems. We don't have any possible divisions by 0 or square roots of a negative number. There's no discontinuity problems here. So this function is continuous. So now I'm just looking for places where it's x values where it's bigger than 0 and x values where it's smaller than 0, less than 0. Now I'm going to pick x equals 1, and I notice that for that gives me a value of 1 cubed plus 1 to the fourth minus 10, which of course is just negative 8. And then I'm also going to look at x equals 2. When I look at that, I see that 2 cubed, or 8, plus 2 to the fourth, or 16, minus 10, that's actually equal to 14. So now I know there is a c where c is between those two values. So c is bigger than 1 but less than 2. And notice it's strictly bigger than or less than because I know what the value of the function at x equals 1 and x equals 2 are. So I know that that point where it's actually 0 has to be between those two, between these two x values. So there's a c where c is bigger than 1 but less than 2, and c cubed plus c to the fourth minus 10 is equal to 0, or c cubed plus c to the fourth is equal to 10. Okay, now there's actually going to be an infinite number of solutions for this problem, because notice if we put in x equals 3, we're going to get something again that's bigger than 0. So you could have, there is a c where c is bigger than 1 and less than, say, 3. It could be, bigger than 1.2 and less than 4. It doesn't matter, you just need to show us that there is one solution. Another possible solution is there is a c where c is bigger than negative 3 but less than negative 2, and c cubed plus c to the fourth is equal to 10. Now you can go ahead and check those values. Notice when we put in negative 3, we're going to get a value that's bigger than 0, and when we put in negative 2, we get a value that's smaller than 0. Okay, the next question is, what is the limit as x approaches negative 2 from the positive side of x squared minus 1 over 2x plus 4? Now, when I try to plug in negative 2, on the bottom here I'm going to get 0. So I know that there's a discontinuity here. And the only thing I need to check now is whether or not it's a removable discontinuity. I know when I put in negative 2 on top, I get 3. So I'm getting 3 over what's going towards 0. So now I need to check if that's actually going towards infinity, or if I have some sort of a removable discontinuity here and I'm approaching some different limit. Now the way that you do that, you use your algebraic manipulation to see if you can get something that factors and cancels on the top and bottom. So the top factors to x plus 1 times x minus 1 over, I'm going to pull out a 2, and this is x plus 2. But notice that these are not going to cancel. There's no x plus 2 on the top. So now I know that this is not a removable discontinuity, and in fact it's it's going to be an infinite limit. So now I just need to check and see what the values are going to be. So the limit as x approaches -2 from the positive side of x squared minus 1 is, that's going to be positive, right? When we square this -2, we're going to get, it's going towards 3. Now on the bottom though, when we put in -2, let's say maybe we put in like -1.9. This is going to be slightly less than 4, and this is going to be slightly less than -4, excuse me. So when we add this, we're going to get a positive number. So this is a positive number over a small positive number. In other words, I know that it's going towards positive infinity. Now let's check this other one. For the same reason, I already know, I could try to factor again, but I know that this is not a removable discontinuity. And now I just need to decide whether it's going to infinity or negative infinity. Now if I put in, -2.1 or something like that to check, I'll see on top here that I'm still getting approximately 3. This is going to head towards 3 no matter what. But on the bottom, if I put in -2.1, -2.1 times 2, that's something less than -4. So when I add 4, I'm still getting a small negative number on bottom. So in other words, I have a positive number over a small negative number, and this is going towards negative infinity.